Welcome to the video, guys. In this video we're gonna revise electrochemical cell. In previous video we learned about electrodes. Here we're gonna learn about electrochemical cell. What is electrochemical cell? Electrochemical cell, it consists of two electrodes in contact with an electrolyte. Let's write the definition. Consists of two electrodes in contact with an electrolyte. In simple terms, we can define electrochemical cell as two electrodes connected together. They are connected together using a conducting wire and a salt bridge. Let's draw an electrochemical cell. This is an electrochemical cell. Copper, and this metal as zinc, and this is metal and metal ion electrodes, and the solution contains ZnSO4 zinc sulfate and the 1 mole Gm-3, and here it contains copper sulfate CuSO4 1 mole Tm-3. This is the salt bridge, this is the salt bridge, and the salt bridge can be NO3, KNO3, and potassium chloride. These are electrolytes, and at the end of the salt bridge there will be jellified agar or cotton wool. It is used as a stopper. This helps to prevent mixing of the contents. This prevents mixing of contents in the salt bridge with the contents in the two beakers. Let's write it down. Cotton or agar. This is the electrochemical cell. There will be a potential gradient between the electrolytes. Electrolyte means the liquid present inside the electrode. Potential generated. Potential generated due to presence of two different electrolyte in electrode compartment, and this potential is reduced by the salt bridge by connecting them using the salt bridge. Liquid junction is called as liquid junction, and this potential is reduced by this potential that created is reduced by salt bridge. And also the liquid junction can be made by permeable membrane, diaphragm, or porous partition. Let's write it down. Liquid junction also can be made by permeable membrane diaphragm, and porous partitioning. These allow passing ions. If we consider this electrochemical cell, there are two half cells, and now we're gonna look at the equilibrium reactions of the half cells. Equilibrium reactions of the half cell. Equilibrium reactions. The first, zinc. Zinc 2 plus 2 electrons, they form zinc solid. And copper 2 plus 2 electrons, they form copper solid. The reduction potential, the standard reduction potential of zinc is equal to minus 0.76 volts, and standard electrode potential of copper is plus 0.34 volts. This minus sign represents that the zinc releases electron more readily than the hydrogen. The zinc release more electron readily than the hydrogen. The plus sign in the electrode potential of copper represents that the copper releases electron less readily than the hydrogen. Now we can compare the equilibria. Here this zinc, it is a minus sign. It releases electron. It should release electron. Therefore, the equilibrium should be shifted to left side. Copper has the positive potential, therefore it should gain electron. So the equilibria favors right side to copper and left side to zinc. We have already learned this. More negative means more negative, release electron. More positive means gain electron. Standard reduction potential, if the standard reduction potential is more negative, it release electrons. If it's more positive, it gain electrons. In electrochemical series, when there is more electron will flow from high electron concentrated area to low electron concentrated area. Here we saw there is more electron in zinc. Therefore, the electrons will travel from zinc electrode to copper electrode. Here the equilibrium shift to left side, and here the equilibrium shift to right side. Therefore, the zinc solid will break into zinc 2 plus and electrons, and these electrons will react with copper 2 plus. These two electrons released are these electrons. These electrons react with copper 2 plus and form copper solid. I'll repeat it again. Here the zinc is undergoing oxidization reaction. So the zinc will form zinc 2 plus aqueous plus 2 electrons, and here the copper 2 plus aqueous plus 2 electrons. These 2 electrons will come here. 2 electrons, they form copper solid. Net flow of electron will be from zinc to copper. When electrons from zinc travels to copper, a current is produced. A current travels in opposite direction of electrons. Here the current is produced spontaneously due to the chemical reaction. Occurrence of chemical reaction is spontaneous, and therefore it is possible we can divide the electrochemical cell into two types. First, galvanic cell or voltaic cell, which is spontaneous. If the chemical reaction occurs spontaneously, it is known as the electrochemical cell is known as galvanic cell or voltaic cell. If the reaction is not spontaneous, it is electrolytic cell. For electrolytic cell, there should be an external source of current that should be supplied to operate. There are two types of cells. First, galvanic cell, and second, electrolytic cell. In galvanic cell, the galvanic cell is called as voltaic cell. In galvanic cell, the electricity is produced spontaneously. Electricity is produced spontaneously. An electrolyte in electrolytic cell, electricity is produced but it is non-spontaneous. We need to supply external current should be applied. In galvanic cell, oxidization takes place at anode. Oxidization takes place at anode. And reduction takes place at cathode. And anode carries a charge sign negative, and cathode carries a sign positive. If an external opposite potential is applied to galvanic cell, the potential increase slowly, and the reaction continues and takes places till the opposite voltage reaches certain value. When the reaction stops, although there will be no currents and any further increase in the external potential, start the reaction but in opposite direction. The reactions will be in opposite direction, and that cell is called as electrolytic cell. If a potential is supplied to a galvanic cell, sufficient potential is supplied to galvanic cell or external current is supplied to a galvanic cell, it will be turning into electrolytic cell. Let's take anode and cathode. Anode undergo oxidization. Cathode undergo reduction, and the potential will be negative in anode, negative potential, and cathode will be positive potential. Electrons will be moving from negative terminal to positive terminal. Electrons will be moving from negative terminal to movement of electrons. What is cell potential? Cell potential is the potential difference between two electrodes in a galvanic cell. The potential difference between the electrodes of the galvanic cell. And also the cell potential is called as electromotive force, which is EMF, electromotive force. Okay, let's write it down. Cell potential, electromotive force. It is the potential difference, potential difference between anode and cathode. Potential difference between anode and cathode. The next one is liquid junction potential. What is liquid junction potential? If there is an electrochemical cell where two electrodes are in two different electrolytic solution, if there are in two different electrolyte solution, and there will be an additional potential difference arise across the boundary, and that arising the arising potential is called as liquid junction potential. Let's write it down. If the electrodes are placed in different electrolyte, there will be a potential arise that is called as liquid junction potential. And this liquid junction potential is minimized using the salt bridge. Salt bridge contains KNO3 and KCl. Salt bridge reduces liquid junction potential. There are some important points when writing the cell notation. Okay, let's first, interfaces should be separated by vertical line. Always oxidation half reaction should be written in left hand sided, and the electrode with reduction half reaction should be written in right hand side. Let's write and look at the other points. Cell notation rules of cell notation. Rules of cell notation. First rule, electrolyte and metal should be separated by vertical line. Should be separated by a vertical line. That is first one. Second one, the salt bridge should be indicated as double vertical line. Double vertical line. The third one is oxidation half reaction. Should be in left side, and reduction half reaction should be in right side. If a liquid junction is present, fourth one, if a liquid junction present, it should be presented in dotted lines. Liquid junction is present should be used should be marked as dotted line in between the electrodes. There can be either liquid junction potential or salt bridge. If liquid junction potential, we should mark it as dotted lines. If the salt bridge is present, we should mark it as double vertical line. The fifth one, physical states must be mentioned. Physical states must be mentioned. Concentration, pressure, temperature must be mentioned if given. If a cell contains zinc and copper, and zinc electrochemical cell, it is called as Daniell cell. Sorry, I missed the electrolytic part. In electrolytic cell, anode and there will be a cathode. The oxidation will occur in anode, same as galvanic cell. Here the cathode will occur in the reduction, but anode will have a positive terminal, positive potential, and cathode will have a negative potential. If we consider this third point, I'll explain this using Daniell cell. If we consider copper and zinc as electrodes, zinc 2 plus aqueous plus 2 electrons forms zinc, and the electrode potential is equal minus 0.76 volt, and copper 2 plus aqueous plus 2 electrons, they form copper solid. Electrode potential is plus 0.34 voltage. How can we find which is anode and which is cathode? By comparing the values of electrode potential. Electrode with less electrode potential means negative electrode potential is anode. Therefore, the zinc electrode will be anode, and higher electrode potential, that will be cathode. Here we are talking about galvanic cell. This solenoid, after this cell notation, it is about galvanic cell. And anode undergo, this is minus means it should give electrons, therefore it undergo oxidation. Anode undergo oxidation. and cathode is positive terminal, therefore it should undergo reduction. It absorb electrons, it gain electrons. Let's write the reaction from the beginning. Zinc solid is converted to zinc 2 plus aqueous plus 2 electrons, and then the copper 2 plus and these two electrons form copper solid. To write the cell notation, we should go like this from here, and then this. We should go like this to write the cell notation. Here first there is zinc. Zinc means anode. We should start from anode. A is the alphabet. Anode A. We should start from anode. Zinc solid. There is an interface, and zinc 2 plus aqueous, and there will be a salt bridge and Cu2 plus aqueous, and this one is okay, done. We have written this, and written this, and the next one is copper solid. This is a cell notation. And now let's look at EMF of the cell. How can we find the EMF of the cell? EMF equal to EMF of the cathode minus EMF of anode. Let's find the EMF of the Daniell cell. Here we know the cathode has plus 0.34 plus 0.34 voltage minus, and here the anode has minus 0.76 voltage, minus and minus 0.76 voltage, and this will be plus 0.34 plus 0.76. The answer will be 1.1 voltage, and it is plus 1.1 voltage. The sign should be mentioned. We can write the cell notation using this flow, and the solid should release an electron, and that electron should be gained by an ion, and it should form a solid. Anode will release electrons, cathode will absorb electrons or gain electrons. Now let's discuss about factors affecting the electrode potential. Factors affecting the electrode potential. Factors affecting the electrode potential. There are 5 factors that affects the electrode potential. The first factor is temperature. First factor is temperature, and the second one is concentration of the electrolyte concentration. The third factor is nature of the electrolyte. Nature of electrolyte. And the fourth one is pressure of the gas. Pressure of gas. And the last one is, fifth one, type of electrolyte. Okay, now let's discuss about different types of electrochemical cell. Different types of electrochemical cell. Different types of electrochemical cells. Electrochemical cells are used to convert chemical energy into electrical energy. And there are primary cell and secondary cell. Primary cell and secondary cell. In primary cell, the cell reaction cannot be reversed by providing an electrical energy. Cell reaction cannot be reversed by providing electrical energy. But the secondary cells are rechargeable. This cell reaction can be reversed electrically. This means it is rechargeable. These batteries are rechargeable cell, and this is not rechargeable, non-rechargeable. Examples: normal Lajetle cell, B Daniel cell. Here the secondary cell, lead accumulator batteries. Lead accumulator, which is car battery. This is the normal Lajetle cell and the Daniel cell. This is the summary of different types of electrochemical cells and their electrolytes, positive pole, negative pole, and their cathode reaction and anode reaction, cell reactions are given. You can take a screenshot now. We learned about galvanic cell. That's all for galvanic cell. And next video, we'll learn about electrolysis. Thanks for watching. Meet you guys in the next video.